Okay, we're going to start out with this initial velocity right here. Because it's at an angle, we can't use it. So what we're going to use instead is its horizontal, or x, and its vertical component. So when we're all finished, our goal is to have our initial velocity in the x direction. I affectionately call this vox, and our initial velocity in the y direction. So that's what we're going to have at the end of the day. And what we're going to do is remember that you can put any two vectors or any number of vectors together tail to tip. And when you do this, you are going to end up with two vectors that, when combined together, are equivalent to the original diagonal vector. And I'm just going to make this one here pink to stay consistent with our horizontal is pink, vertical is blue, and there we go. So I can replace this purple vector with the pink horizontal x vector and the blue y vector. And as always, I just want to keep an axis in mind so I can define what is positive and what is negative. So this axis is telling me if I'm moving to the right, I'm positive x. If I'm moving to the left against the axis, I'm moving to the negative left. Upwards is positive y, downwards is negative y. So this vector right here will be our initial velocity x component, and this vector here will be our initial velocity y component. Now the challenge is going to be, and it's not really a challenge at all, well, not after you watch this video, is going to be, okay, how do I figure out what those numbers are? Well, let's first give these numbers. Let's say that my initial velocity is 5 meters per second. Let's say it is an object, maybe it was kicked at an angle of 10 degrees at 5 meters per second. Well, this all should bring back some memories, and they may be bad memories, and if they are, I want you to erase your mind of that and start fresh, because I'm going to show you a no-fail system that if you follow it, as long as you follow it, it will work for you every single time. Any student who struggles with this after I teach it, I have noticed, is not using the system, is not using every step in this. Oh, I don't need to do all those steps, and then they go ahead and get it wrong. So if you do this the way that I teach you, I promise you, you will never ever get it wrong again. So we all can recognize at this point, and I'm looking for, there we go. We all can recognize at this point that this here is a right triangle. So we can recognize that we're going to be dealing with sine, cosine, and tangent. Now I am smart enough to realize I shouldn't say the T word. Trigonometry. Oh, I said it. Because that may or may not bring up bad feelings. I have an idea if it doesn't bring up bad feelings, you want to be watching this video. So, but I'm going to show you how easy it is. And this is just one itty bitty aspect of trig, but I'm going to show you how easy this is to use. Step 1. Identify your sides. Okay, so step 1 is going to be identify your sides. And what I mean by that is we're talking about opposite, hypotenuse, adjacent. Let's identify them here. I think it's easiest to identify the hypotenuse. So we're going to put a big fat letter H in a circle so we don't get it confused for variable on our side that is the hypotenuse. The hypotenuse is always going to be that angled vector, the one that you started with, your original velocity or the original force that's at an angle. Now, whatever angle you're using other than the 90-degree angle, here we're given 10 degrees. That is our angle of choice. Only focus on that angle and now identify the other sides. Well, This side here is attached to that angle, as is the hypotenuse, and the attached side, all those trig people call that adjacent. I call it attached. It has more meaning. The attached side is going to be this side of our triangle, and the opposite side is simply the side that's not attached. Boom! We just identified our three sides. Step 2 is going to be determining what we're looking for, which side we're looking for, and what we're given. So identify, and you really want to pull out letters. Maybe we'll just call it that. Pull out letters of our known and unknown. Well, in this case, we have two unknown sides, don't we? So we're going to choose. Let's first do Vox. Let's first determine what this X component is. Okay, well, I'm going to pull the letters out. I'm looking for A. So I'm going to write that letter down, A. I know my H, and I get it. I have AH, so I find in my SOHCAHTOA up here which three letters have in it. Well, this has an H but no A. This here has, there's right there. Ka has both an A and an H in it. So we are going to use Ka. Now, don't forget, each one of these stands for an equation. So represents sine theta equals opposite over hypotenuse. Cosine theta is Ka is cosine theta equals adjacent over hypotenuse. And TOA means tangent theta equals opposite over adjacent. Now some of you may be like, but I don't know what that means. Just relax. Take it in. You will know what it means in a little bit. All right? So because my A and my H are in the Ka, that means I'm going to use this equation. So I'm going to go ahead and use this equation. So step 3 is choose the equation just like we did. Choose the question. No, choose the equation like we just did and solve for the unknown. So those are our steps. I'm going to erase that so we have some more room to write. But I'm now going to use my cosine theta. And it's always, I always tell my students, you should always write down the original equation first. That way, if you do make a mistake, you can go back and easily determine where your mistake was made. We're going to substitute in the angle. Remember, an angle always is what comes after cosine, tangent, or sine. A adjacent is Vox. Down here, I go back and I look, okay, we identified that as our initial velocity in the x direction. My hypotenuse is my initial velocity, and we had that as 5 meters per second. And now I just solve for Vox by multiplying both sides by 5. And now I just plug that into my calculator. I'm going to use my very high-tech calculator here. So cosine 10 is equal to 0.9848 blah 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 times 5. And I see that my velocity component is 4.924 meters per second. Now I see here I only have one sig fig, but I am always going to take it out many decimal places. That way I won't end up with a round off error in the end. Now I'm going to do the exact same thing for that y component. Watch this. I already have my sides defined. I'm going to leave them as they are. If I mess around with how I define my sides or I change my angle at this point, I'm going to run into trouble. So the side that I know is H. The side that I'm looking for is my initial velocity in the y direction. Oh, I see. Well, the only three-letter acronym I have here is the SOH. That's my sine equation. So now I know which equation to choose. I'm going to write down my original equation first. Just don't confuse this O for a 0. So our angle is 10. That'll be sine 10 equals opposite, which is void, divided by our hypotenuse, which is 5. Some of you may say, well, I decided since we already solved for Vox, I use tangent. You can do that. Just be careful to take it out enough decimal places. The one reason why I wouldn't do that is if I had made a mistake, which rarely, all right, it does often happen. If I had made a mistake with that initial velocity in this direction, well, now my velocity in the y direction will be wrong as well. But that's why I always go sine. But technically, you could use tangent and use this side and this side to solve. That's up to you. So I multiply both sides by 5. And now I take out my very high-tech calculator. I'm sure you have one on your computer that looks exactly like mine. And I find out that my initial velocity in the y direction is this. Now I am going to keep it out a few decimal places because these numbers, this is just the beginning, because these numbers are going to go into future calculations. This was just one step towards solving. This is like an on the side step. There you go. As long as you always identify your sides first, pick out the letter the side that you know and the side that you want to know, it's going to be a no sweat process. Make it a great day.